Alright, so the last type of transformation we're going to look at is the translation or slide, and there's a reason I left it as the last one, even though it's one of the more popular ones. It's a little more difficult than the others in terms of it have a little more maths involved. You might see a little algebra as well, as you'll notice, right? So a translation is moving an object to a new location, but we're not changing anything about it. We're not changing its size, its shape, or its orientation. And the example I normally like to use is the fridge magnet, right? So I have my fridge magnet there, and I just don't like how it's looking there. I want to move it to the next part of my fridge, so I just slide in it to a different part of my fridge, or whatever I had, I just want to move it to a different location, so I slide it there. Whatever I have, I want to move it to a different location, so I just slide it. I just moving it to a new location, but you realize nothing about it. It's the same exact shape, size. It did not turn, so the orientation is the same as well. I'm just moving its location to a new location. And with this one, the extra info that we're going to require is directions to that new location. And the direction will take the form, since we're dealing with graphs here and graph pages, it'll take the form of something called a column vector. So this is going to be the column vector that we have. And you realize it's very similar to a point, because a point is normally be x comma y. Column vector is the same thing, it's just rewriting it top and bottom, by the way, right? So we're taking these two numbers, as you'll see when we're looking at the examples in a little while. So that's our column vector there. But what does this column vector mean? So just like with the point, this x value talking about on my graph, you realize the x's go, the x-axis runs like that. So that's talking about horizontal movement. So once I can move horizontally, that's what that would talk about. But horizontal have two directions. I can move forward or backward. So if this is a positive value, that means we're moving how much ever the number is, because x just representing a number. We're moving in that direction, forward or to the right. If x is a negative value, well, we're moving in the opposite direction, backwards or to the left, how much ever units this number is. Same thing with the y. In the y-axis runs up and down, because again, this is my x-axis, this is my y-axis, right? So the y-axis will talk about vertical movement, the y value, sorry. And again, we could have two sets of vertical movements. I could either go up, and up we given the positive value, how much ever that number is, as you'll see, and down will be negative. So again, you can see this one a little bit different than the others. Translation means we're moving and changing the location, but the extra piece would be I need to give directions, and the direction is going to take the form of this column vector. And as usual, you'll see it a little better in an example, but it will have numbers here. The top number, which is the x value, refers to the x-axis. I'm talking about horizontal movement. Positive is forward, negative is backward. Y value refers to, again, to be a number. The vertical movements, positive is up, negative is down. And as usual, let's see if a example would help out. And we're going to look at a past paper question as our example. Let me zoom out so we can see a better. So we looked at this one earlier when we did the enlargement. We didn't look at the first part though, which is what we're going to look at now. And we're going to see two ways how to do this, and that's what will be a little more important. You need to know one of the ways more than the other, but you can double check the physical way after. So let's see how to do this. So L is mapped onto M by a translation. So again, L is the original, M is what taking place. So I'm moving from L to M. Here they didn't use L and L prime, but this is the same thing as L with the little one on it. They use two new letters. State in the form XY, the vector which represents the translation. So they tell me it's a translation, and they want the column vector. So the two ways I could do it, we could do it physically once I have the graph, and then obviously the mathematical way is very important as well. So let's look at it mathematically first. So what really taking place is you have to line up the points. So this point here going to end up here when I slide it. So we'll call that I'll just call it 0.1 for this example, right? So 0.1 going to end up 1 prime there, right? What's the coordinates of 0.1 though? So the coordinates of 0.1, and again, you need to know how to read off your points. X first, y after. So the coordinates of 0.1 is, I'm going to write it here, is -2, -1, because x is -2, y is -1. And he's going to end up, when I map it and do this translation to it, he's going to end up here. What's the coordinates at this point? Again, x value first, y value after. X is 2, y is 3. So that's what happened to that point. And I could do the same for the other points, right? This point going to end up here. This point going to end up here. And we'll do those after as well, just to show you. All I need to do is 1, and once I do it correctly, it'll be fine. And then I could show you it physically as well. So what's going to happen is, we're dealing with a column vector. They want it to look in this form here. So I'm going to change everything to a column vector form, which means I'm just going to rewrite this. So instead of having x comma y look like that, I'm going to write it x, y, top and bottom. So now I have -2, -1. So again, I'm writing it in my form x, y. And when I do the translation, when I give my directions, I'm telling you where you want to go. So I'm going to add the column vector x, y to it. You're going to end up at 2, 3. So this was the little bit of algebra talking about. So realize we have two equations here. The first one, and I'm just writing it out separately so you can see it. You don't have to do it out separately. I'm just showing you what's taking place. -2 plus x is equal to 2. And -2 plus x is equal to 2. I want to solve for x because that's what I really want. And if you remember how to solve stuff, all the letters are going to go on one side, all the numbers are going to go on the next. So an easy way to remember it, I'm going to carry across the -2, or in other words, I'm adding 2 to both sides. When I carry across the -2, what's going to happen? The sign is going to change from -2 to 2 plus 2. So x is 4. So that means I already find x is 4. One of my numbers already obtained. And now I'll do the same thing for y. -y plus 1. Now some people could do it in their head right here and see it is equal to 3. That's the second part. And then again, like before, I'm going to take u and carry across. When I carry across, the sign is going to change. So 3 -1 going to change to +1, 4. So both of them turn out to be 4, which is just a coincidence. So the answer for this one is 4, 4. But what does 4, 4 mean? What does 4, 4 mean? 4, 4 means, if we look back at this here, that means I'm moving +4 blocks forward. Because as a positive number, I get 4 blocks forward. And after I move 4 blocks forward, I move 4 blocks up because it's a +4. We don't need to put the plus sign. So let me see what it means physically. So physically, if I start off at this point, +4 for the x means I move 4 blocks forward. So I jump 1, 2, 3, 4 blocks forward. That's where I reach now after I move my x4. And so that's my 4 forward because it's a +4. And when I finish moving my 4 forward, I'm going to move y4, which means 4 up because it's a +4. 1, 2, 3, 4. And you realize it end up at the same point. And I could do that for each of the points. 4 forward, 1, 2, 3, 4. 4 up, 1, 2, 3, 4. That point going to end up there. Same thing here. 4 forward, 1, 2, 3, 4. 4 up, 1, 2, 3, 4. He ends up here. And again, we could do it mathematically if we like. Take the coordinates of these points, add 4, 4 to it, and get it. So that's what it looks like, but I want to show you a next one because we have several on this sheet that I normally would use for you all in class. Look at the next one here. Let's take a look at this one. The figure labeled P undergoes a transformation such that its image is Q. So P is the original, and we go into Q. And we realize it didn't tell me what type of transformation it was. Describe this transformation completely. 2 marks. And the reason it's 2 marks is 1 mark for saying what type of transformation it is, and then the next mark for the extra info. Because like I said, all of these have extra information. So what type of transformation it is? Well, you realize it didn't turn. It's not a reflection, obviously. It didn't get bigger. So it's a translation. I just slide this to a different point on my diagram. And 1 mark for saying is a translation. But once they say describe this completely, that means now I need the maths part of it, which is the directions. So I could do it physically or I could do it mathematically. If I have the diagram, I might be able to do it physically. If I don't have the diagram, then I have to do it mathematically. And sometimes they just give you the points. So pick a point. You pick whatever point you want. I'm going to pick this point here. And where's the corresponding same point on the next diagram? It's going to be here. Right? That point and that point is the same point. It's just on the object and the image. What's the coordinates at this point though? So again, you have to know how to read off a coordinate. The coordinates at this point, x is 4, because on the x-axis, it's on x is 4, y is 2. So I have that first point I'm going to use is 4, 2. So that's that point there that I write up. And the corresponding point, what the corresponding point going to be? So again, I find my x value first. This is the x-axis. X is 6. But this time y is, well, I've seen minus 4 and minus 6, and it's exactly in between because you realize they count in 2. So here going to be minus 5. So 6 minus 5. And that's what's happening. That's the transformation, sorry, the translation taking place here. And I'm jumping from 4, 2 to 6 minus 5. So, again, this is x comma y, but I want xy. So I'm going to change this from top and bottom, left to right to top and bottom. So this is going to change to 4, 2. I want to add, this is the translation taking place. I'm going to get my answer, 6 minus 5. And this is what I want to solve. So, again, you could do it in your head, or you could write it out. 4 plus x equals 6. This one might be easier, but the second one mightn't be as easy. So 4 plus x equals 6. Carry across my 4. So to be from positive 4 to negative 4. So x is 2. Second one, 2 plus y equal minus 5. Carry across that. Y is equal to minus 5 plus 2. Sorry, no, to be minus 5 minus 2 when I carry it across, because it's already a plus. So minus 5 minus 2 minus 7. So what this means is the translation vector that I wanted, x is 2 and y is minus 7. And I finish. But always safe to double check. So we get 2 minus 7, right? That's what we found out the translation vector to be, 2 minus 7. But what does that mean? And like I said, the top number talks about horizontal movement, the bottom number, vertical movement. So x is 2 means I'm moving 2 blocks forward. That's what the top number means. Sorry, x is 2 means I'm moving 2 blocks forward. So when I move my 2 blocks forward, I'm going from here to 1, 2. That's where I am right now. I'm moving 2 blocks forward, and minus 7 means I'm moving 7 blocks down, because we have a minus this time. So I'm going to check my 7 blocks down. 1, 2, 3, 4, 5, 6, 7. So 2 blocks forward, minus 7 blocks down, and you realize I end up at that same point there. And I could have checked it physically. Let me check it from this point to this point. Move your 2 blocks forward. 1, 2. So that's my positive 2. And then my 7 blocks down. 1, 2, 3, 4, 5, 6, 7. I wonder if we have time for one more, but let me see. We'll stop with that one. And I'll give you one to try on one of the worksheets that we're going to use next. But that would be the different types of transformations. They have 4 types: reflection, rotation, enlargement, and translation. But it's not enough just to say the name and what type it is. You have to describe it by giving that extra info, and each one of them have some extra information. And we'll be looking at multiple choice questions first, because they come very often in the multiple choice paper, and then we might look at some structured questions after. So that's the basics of transformations.